Good morning, ladies and gentlemen. Through this video of mine, I would want to introduce you to the basic hypothesis test that you conduct when your y and x are both continuous data. In my preceding videos, you would have understood by now that the decision on what test do we conduct will completely depend on the data type of your x and y. And here in this video, I would want to discuss with you the option of when y is continuous and x is continuous. Something like, I'm a car making company and I want to understand whether the mileage of my car has something to do with the age of the car. Mileage of the car, something to do with the weight of the car, etc. In such cases, you have two options. You have the option of conducting correlation test and the regression test. Correlation test is to be used, as I discussed, when y and x are both continuous variables. When you conduct a correlation test, it essentially checks if there is any significant relationship between the variables. Null, in the case of a correlation test, will say there is no significant relationship between the variables. Alternate hypotheses, on the other hand, will say that there is significant relationship between the variables. Typical examples could be, you would want to understand that whether the amount of money being spent on advertisement has any impact on sales or not. You would want to understand, as a BPO leader, if the handling time of a particular activity has something to do with the tenure of the employee. Mileage of the car related to the age of the car. All this could be tested using a correlation test. However, one very important thing to understand during a correlation test is that correlation does not identify x and y. It treats both the factors as variables. It is unable to identify causality. It is unable to identify dependent-independent relationships. For a correlation test, it will find out if both the variables are related to each other or not, and it will not be able to tell you whether the x impacts my y or not. And the strength of the relationship during a correlation test is depicted using a R value, or a Pearson's correlation coefficient value. R value, which is closer to 1, would mean that there is a positive correlation between the variables. R value closer to -1 would mean that there is negative correlation between the variables. And similarly, if R value is closer to 0, that would mean that there is no relationship at all. So if you are conducting a correlation test, let me see if I can do that for you. Yeah. So correlation test would lie in the stats area. Stats, basic stats, go right, correlation. Choose both your variables. I am looking at the total breakage quantity, which is in kilos, versus production in kilos. I press OK. The first thing that you should look at is the p-value. Here, if you see, the p-value is being shown as 0.000, meaning both the variables are related to each other significantly. Additionally, it also publishes for you the Pearson's correlation value of 0.289, closer to 0, which means while there is relationship, it might not be significant. Additionally, the second test that you have the option of doing is a regression test. Regression is an alternate to your correlation test. Again, when do you use it? You use a regression test when both your x and y are continuous variables. Null in this case will say that x does not significantly impact my y. Alternate will say that x significantly impacts y. Please remember, if you remember the correlation test that I was talking to you about, I said in a correlation test, the null said variables are not related to each other. Here we are saying the factor impacts my y. The same examples of impact of advertisement on sales, impact of tenure on handling time, impact of age on mileage, etc. could be the examples for a regression test. And much like the correlation test, the magnitude of relationship of X and Y is depicted in a regression test using a R-square value. R-square value, also referred to as coefficient of determination, helps you understand the percentage variation in Y as contributed by X. So assume that the total variability observed in my Y is, let's say, a 1400, out of which 1000 comes from X. So my R-square value will become 1000 upon 1400 into 100. R-square is always a percentage. And the industry uses a standard of 62% as significant magnitude for R-square. And R-square is a super important value when you are doing screening in the later part of your project, when you are to prioritize which X would you want to work on. R-square value could be a great mathematical value for you to decide which X should I work on more and which should be a lesser priority. Additionally, the regression test will also help you with a regression equation or a transfer function in the form of y is equal to mx plus c. This regression equation will help you determine, understand, predict sometimes the relationship between x and y. So let's assume that we've received a correlation, a regression value, regression equation of sales is equal to 4 lakhs plus 14 times the advertisement. So if you were to choose for yourself that I am willing to spend 10 lakh rupees as in my advertisement, you will be able to calculate how much you should expect as sales of the sales for that particular time. Let me help you with this on the Minitab. Regression will again lie in stats, regression. Choose in the response column, choose your Y, which is my total breakage here, and X, which is the production in kg. Press OK, scroll upwards. If you see here, it is saying production and it gives you a p-value. It is giving me a p-value of 0.000, which means X significantly impacts my Y. However, the R-square value is very small, 8.3 only. So the percentage contribution of X on Y is only 8.3%. Additionally, it also is giving you a regression equation. Total breakage equals 6.05 plus 0.0198 times of production in kg. I hope this simple video helps you understand the basics of correlation and regression. Thank you.